Hello everyone, welcome to my YouTube channel. Today I'm talking about solving the Leetcode question 1020, number of enclaves, using the depth-first search method. So if you are not familiar with this type of question, I would recommend first checking the video for Leetcode 200, number of islands, and then also my video for solving the Leetcode 695, the max area of the island. After after checking out those videos, you will probably get a much better idea on solving this problem. So let's try to first understand the problem statement. You are given m times n binary matrix grid, where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent, four-directionally land cell, or walking off the boundary of the grid. We want to return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves. So let's try to understand the problem a little bit better through an example. Let's first take a look at example 1. So given this grid, so there are two islands in this grid. One island is adjacent to the boundary of the grid and then it's highlighted yellow. So this standalone land cell itself is an island because it's not connected to other land cell in four direction. Four direction means horizontally and vertically. Let's say if you move up, move down, move left, and move right, if after moving in all those four directions, you find there's no other land cells connected to this land cell, then this land cell itself is a standalone island. There's a second island in the middle of the grid, and then this island is actually completely surrounded by water in all four directions. So if you look at the cells above this island, going up, going down, going left, and going right, you will see that this island is completely surrounded by water in all four directions. So this island is actually the island we want to keep track of the total number of cells. So we call this island a valid one. So there are three cells on this island. So in this case, the output value is 3. So let's take a look at the second example. So in this case, the grid only has one island. And then this island is actually connected to the boundary of the grid. So for example, if you move from this land cell, going up, you hit the boundary, you can walk off the boundary of the grid. So this island is not a valid one. So in that case, we just return 0. So now let's think about how we want to solve it. So basically, we want to know if an island is a valid island or invalid island after we finish traversing through all the land cells on this island. So in that case, we want our DFS function to return a Boolean value to indicate, yes, this island is a valid one because it's completely surrounded by water in all four directions. Or no, false, this island is not a valid one because from some land cells on this island, we can actually walk off to the boundary of the grid. And then since we need to count the total number of cells on those valid islands, we need to keep track of the number of cells where we for each island where we traverse through all the land cells on that island. So after discuss the idea of solving it, so let's start coding. So first, let's get the dimensions of this grid. M indicates the number of rows and indicates the number of columns. So it's kind of my habit to actually start coding with the main framework before diving deep into the DFS function. So let's start with the total area and then initialize it to 0. Basically, we use this to keep track of the total number of cells from all the valid islands in this grid. And then we are trying to traverse and visit every cell in this grid. If this cell is a land cell, then that's our starting point for visit all the adjacent cells. We also want to keep track of the area of each island we traverse. So in that case, before start visiting and traverse the island, we initialize a variable called area. And then we assume that we will keep updating this area while we're traversing every cell on that island. So we call DFS. So basically after this DFS function return, then we know that we finished traversing every land cell belong to the same island. So remember we talked about we have a Boolean variable to indicate if this is a valid one. It is true if it's a valid island. So in that case, we just add area to the total area. And then we can just return the total area as the output of the solution. So in that case, so let's code up the DFS function. So DFS ij, which means we start visiting the cell with index ij. So at the beginning, we want to declare our area as non-local. And then we want to check the condition. Let's say if this grid I, j hits the water boundary. In that case, we return true. We know it's surrounded by water. We also keep track of if the cell has been visited before. For any cells that were previously 1, which means that cell is a land cell. After we visit that cell, we change the value to 0 so that we keep track of the visit cell in place without utilizing any additional data structure. So in that case, this also denotes already visited or hit water boundary. If we hit the boundary of the grid, then we know that this island is not a valid one. In that case, we return false. Okay, now start visiting the cell with index ij. We first mark it as visited. And then we increase the area by 1 because we visit this land cell on this island. And then after that, we need to go up, down, left, and right to visit its neighbors. So we need to get the index of their neighbors. Going down, going up, move left, move to the right. So, okay, we want to keep track of if all the neighbors are actually valid. So in that case, let's keep initial Boolean variable. And then while traversing through each of the neighboring cell, we just keep update this variable. After that, we just return. So which means, so what does this mean? Which means, okay, from index ij, we move in 4 directions and visit all the 4 neighbors. If any of the neighbors return false, in that case, we know this island itself is not a valid one, so we just return false. If all the neighbors are actually valid, so in that case, we just return true. Okay, so let's try to run the solution. Oh, oh, my bad.